tired. Ready? All right. Hello, everybody. My name is Aaron Delp, and here to talk to you a little bit about OpenStack Cinder, block storage, and how that relates to SolidFire as well. But before I do that, I have to really start with a foundation. Out in the industry today, there's really three types of storage. You have block storage, object storage, and file storage. Within an OpenStack context, we refer to two of those today. We talk about block storage, which can be referred to as Cinder, the Cinder project, and then object storage, which is Swift. There is a proposal for a file-based project as well, but that isn't currently in OpenStack today. But let's compare and contrast these a little bit so you can see where we are going with Cinder versus Swift. The objectives of the different projects really lead to different use cases and different workloads. So let's look here. On the left-hand side under objectives, we have the storage is really for running the VM volumes on a host under Cinder. It is ideal for your higher performance, performance-sensitive kind of workloads and applications, as opposed to Swift with object storage, really a very different model under the covers and a very different use case of ideally more of long-term storage or cost-effective, cost-sensitive scale-out kind of environments. But the use cases that lead from those objectives of the projects, actually production applications, traditional IT under Cinder, under Swift, a lot of times we're seeing VM templates, ISO images, disk volume snapshots, using this almost as a secondary tier, if you will. Now there are some applications out there that absolutely use this, some web scale kind of applications where that primary performance is secondary to that scale out aspect of everything. And then lastly, the workloads. The workloads we're looking at really, especially under Cinder and block, a lot of high change content. The Swift stuff tends to be more static. It may be accessed a lot, but it tends to be more static in its delivery. Now, if I take all of that information from previously and say, what is the actual design or objective of Cinder? Well, what we're looking at here is traditional block level storage. So your traditional SANs that have been around forever, this is how a traditional block level SAN will talk to OpenStack through the Cinder project. And what happens is it manages the creation, the deletion, and the presentation of those volumes through various different ways. And this slide here really tells us about how Cinder works. So first of all, there is a default implementation. You don't even need necessarily shared storage or a SAN to make all of this work. You could actually just do it with commodity hardware, commodity servers, and really get this going with what we call the LVM and iSCSI implementations. But more times than not, when we're talking Cinder, we're talking about the plug-in architecture, a storage array actually plugging in, and that abstraction layer is created then where OpenStack and a user or a super user or an administrator isn't necessarily talking directly to the array. They will talk to the Cinder layer. And that Cinder abstraction layer will then turn around and talk to the array. And it could be more than one type of storage behind that, which is a key here. You can have multiple backends and multiple plugins and only manage it in one central way, and that is through the Cinder environment. And one of the, this gives us a lot of different advantages when we actually talk about those plugin choices. Obviously, one is that multiple storage types. If you want to bring in another storage array into an environment, you can absolutely do that, but you can do it and manage it in the same way you're managing your other OpenStack Cinder environments today. And you have some flexibility there. You can add devices, you can also remove devices. You can actually do transitions from one type of storage to another type of storage through this. And so we like to talk about enterprise, and what does that mean for an enterprise storage administrator? Well, because of this abstraction layer, much like virtualization with compute, you have a very simplified operations model. You have simplified scaling, simplified HA, and that storage is actually tested and supported because that plugin will be tested and supported in order for it to be really checked in, if you will, to Cinder. There is a known set of functional tests that have to happen. So we're looking at really the idea of creating something once and reusing it many different times. And that is actually where SolidFire comes into play with all of this. SolidFire, what we actually do is it's scale out all-flash, high-performance, guaranteed performance storage. And what we mean by that is this really was designed from the ground up for web scale, cloud scale type of environments where we're not looking to be a point solution. We're not looking to just run one tier 1 application on a storage system. How do you actually run multiple hundreds, if not thousands, of tier 1 applications where you guarantee the performance and guarantee the quality of service in a multi-tenant environment? And that's what we're looking to do here. How do you bridge that gap between this kind of storage system and OpenStack Cinder? And operations over time. How do you do that in an automated fashion? Well, what we actually do is we have a fully REST-based API in addition to the guarantee of the performance earlier, and this allows us to really provide some very unique advantages to our customers. And wanted to summarize all of that very quickly on this slide of, again, fully certified and tested SolidFire to Cinder, the ability to set and maintain quality of service for multiple applications or multiple tenants, and that offloading of basic Cinder functionality, if you will, snapshotting, cloning. You can actually manage the volumes from the OpenStack interface. And then you can actually create bootable SolidFire volumes, and the web-based API is all there for the day-to-day functionality you may have to run into here and there. And you can actually configure this very, very easily. So what we're doing here is you actually go into cinder.conf file, you add in, it's either 3 or 4 lines, and you're off and running. So the automation, the configuration of this, very easy, very slick, very well tested, and very functional, and a lot of service providers and enterprises that are picking up on this and running with it. And with that, thank you very much.